All right, so bottom of page 46, section 2.2, moving from one graph to another, okay? And you will notice the chart on page 47 is what was provided to you yesterday. It's up here on the screen. I think do you have that? Or maybe you don't have that yet.
Yeah.
You do have that? Oh yeah, I gave it to you the crazy power outage thing. Okay, so could you find that? Because what we're going to do is you'll notice that the last three columns have disappeared. Someone has rudely taken those away. And you need one, Jenny, do you? So what we're going to do is we're going to fill in those blanks. Okay, so bottom of page 46. 217 summarizes, do you need some, Jared?
No.
Summarize all the possible dt motions with the corresponding dt graphs and acceleration values. We can use, okay, Brendan, I've started. Now is the listening time. We can use the graph segment shown here to create dt graph sketches and dt graphs, vice versa. So you're going to use this as sort of your reference when I give you other graphs to sort of put the pieces together, if we will, okay? So all I'm going to do is I'm going to recreate what's in your book on paper, and you're going to write it down because that's going to be a better way for you to make an understanding of it, is the theory behind it. Okay, so when the object is stopped, the dt graph, now you have to look carefully there at the book, but the graph itself, I'll just do this, I'll put this in blue, that's the axis, and the graph itself is right there. So when it's stopped, right, the vt graph is going to be right at zero, isn't it? Right? The vt graph is right at zero. So a flat dt graph gives you a flat vt graph right at zero. And that means then that the velocity is equal to zero. And if the vt graph is flat like that, then that means that the acceleration is also zero, right? And if you think about a track and field athlete, and I'm going to be drawing stick figures here to show off my drawing ability. Feel free to laugh at me. I'll be coming by to judge you as well later. This is one of my favorite lessons, just because I get to do this. In stick figure format, yes. There you go. How's that? Okay, so this person is stopped, ready to run the race. Right? You guys have to follow along. You can't just copy it down. It's not good enough to copy it down. Okay? It's about understanding and getting it, and you have to stop the side conversations. Okay? I really want to leave the five of you sitting together, but it's not going to work the way we're going. Okay, so the other possibility about stopped is that the graph could also look like this. There's zero, and I guess maybe I should mark 0 on there, like so. And this means stopped. Right? Again, VT graph right at 0. You'll notice that these two are the same, even though these two are different. Okay? And again, here the velocity is 0, and the acceleration is 0. And how do they show that from a real-life personal example? Well, what they did was they take this person, and I'm going to cheat. Come on. Now, discuss. Correct? Incorrect? Do you see any issues with that? Or you're okay with it? Well, true enough. And just because the DT graph is below 0, does that mean the person is automatically facing the other way? All it means is, let's talk about the first one. This person or object or whatever it is stopped and is to the right of the origin. So really, I would say the first one should have a starting line like right there, and the person is stopped in front of it, and this one should really be what? I think should be like this. Oh, half a person. Oh, I know why. Group them together. Where's group? I think it should look like this. They're stopped, but because they're at negative, it just means that they're what? Behind the starting line. Would you agree with me or disagree with me? And feel free to disagree. It is a free country.
Depends on the situation.
I would, yeah, right? I just wanted to point that out, right? I think that necessarily, just because you're stopped in the negative doesn't necessarily mean you're pointed that way, right? Could it also be like this? There's no reason why it couldn't be, right? But I think it's more important to show that the person is stopped behind the starting line than the direction that they might go. Because they could, like, be facing that way and then turn around and go the other way, right? So I don't think that the direction that they're facing really matters in this case. Anyways, let's move on. Are we all good with that? Yeah? Okay. So the next one here, sort of cut off. I don't know if yours is cut off. It's constant velocity. I'm going to, in keeping with what I've done here, I'm going to go blue for the axis, and I'm going to go red for the actual graph here. So constant velocity, the dt graph is like that, right? The slope is constant, which gives my vt graph. The slope here is positive. I'm going to write in here positive slope, and so I have to graph positive slope. Is it constant? It sure is. So you'll notice these have similar shapes. This one just is above 0. These ones are at 0, right? The velocity then is some number greater than 0, or you can say positive velocity. And what about the acceleration? Is the acceleration 0? It is. How can you tell? Because the slope of the vt graph is flat. So again, the acceleration is 0. Moving at a constant speed. This runner is doing what? Cruising at constant speed. Make myself some room here. And see if I can draw this. Oops. You know those figures in the gym, the running figures, those figures on the wall? Did you know that I painted those when I was in school here? I made that up just now. It's not true. I just made that up. Complete lie.
You didn't even go to school here.
Yeah, we remember the quiz.
Okay, just checking to see if you're listening. You all know about my life. There you go. There's the skinny, bald-headed stick figure running at a constant speed.
Hey, it's you.
Yeah.
Oh,
I wish I was that skinny.
I know.
Okay. Now, where's the starting line? According to the graph, I guess they started, right? And they're running at constant speed, I guess. They started at 0 and they went at a constant speed. I don't think the starting line really matters that much there. Is that all good? Chandler? Am I making sense? Okay. And this is all still kind of that review from grade 11, right? We're going to move past that real soon, starting Monday. Okay, constant velocity. This time here, we've got it like this. That's marked 0. Oh, I did that wrong. I did, didn't I? Did it wrong. There's the graph axis. The graph itself is like this. Whoops. Which just means moving at a constant velocity, but in the negative direction, right? Still flat. This time here, my velocity is negative, less than 0, right? The graph is below, it's negative. And the acceleration, 0. How come? Because the vt graph is flat. Okay, this person is running at a constant speed. backwards. So it's exactly this picture right here, which I will try to combine. Copy. Paste. Oh, I missed the head. Yes, it's the beheaded runner. There we go. Running at a constant speed to the left. Yes, good. How many people have completed the chart already? And have you done it with thinking or just copying? Okay. Speeding up means, right? DT graph is curved, slope is changing. Here, the value of the slope is increasing at a constant rate. You'll notice that it's not flat anymore, but it's still straight. The velocity is above, which means the velocity is positive, above zero. And because we now have a positive slope, that means that my acceleration is also positive, above zero. And if the velocity and the acceleration are both in the same direction, both positive, then that means that this person is actually accelerating, speeding up. And that would be shown like this. Right? They're speeding up. And if the graph is curved the other way, you'll notice that the slope is still increasing. It's still getting steeper, which just means that the value of the slope is getting steeper. It's getting larger but more negative, right? So it's moving away, becoming more and more negative. Here the slope is becoming more and more negative. Here we have negative slope. The velocity is below zero, so my velocity is negative, below zero. And my acceleration is also negative. And when they're both in the same direction, both positive or negative, Dylan, and that means that it's speeding up. Okay, so it means the stick figure person is accelerating in the next other direction here. Right, like that. And the last one, slowing down. Slowing down means that the slope is flattening, becoming more and more zero. There's the axis, right? The slope is steep and then it becomes zero. So I'm graphing the slope. It's up positive and it goes towards zero. We're going to have issues, gentlemen. Here the velocity is above zero, positive, but the slope is negative. Less than zero. Which means that the person is slowing down. Just like Usain Bolt approaching the finish line, celebrating early. Hands in the air. There's a reason why I don't teach art. I'm much better at this than that. Art is my middle name. Not. All right. Camart. just like my email address. Slowing down, again, but in the negative direction, right? See how the slope approaches 0? So the graph here has to approach 0. The value of the graph is approaching 0. Again, we're going to be using these to do the conversions right away, right? So the velocity here is below 0. Velocity is less than 0. But here we have positive slope, which means my acceleration is greater than 0, which means that it's slowing down. When the velocity and acceleration are in opposite directions, you're slowing down. Here the velocity is less than 0, so that just means he's slowing down, running to the left. Slowing down and running to the left. I'll pause there for a second. So we're going to take those bits and pieces and we're going to take real graphs now and we're going to sort of construct. I think the next page that you have looks like this, am I right? Is that what you have on the next side? The flip side? Yes? Okay. Okay, so that is on page 48, converting a DT graph to a VT graph. And you've done a little bit of this in grade 11. This is sort of the next step, right? So DT. Now what they do is they recommend you draw the axis right below, and they want you to sort of line up these points. Like this is a critical point because the thing changes. I found over the years that things like that are extremely difficult to do. So I'm not going to mandate that. I found that it's very tough to do. Okay, so don't worry so much about that if that doesn't work for you. We are graphing here. We are graphing the slope, right? We're going to take the slope and we're going to graph the value of the slope down here. Okay, so let's look at this first initial interval here. How would you describe the slope right there? They've even got a tangent line. How would you describe the slope right there? Monique? What would you say about the slope? Is it, I'll give you options. Is it positive or negative? Positive. It's positive. Okay. Is it very positive, somewhat positive, or just barely positive? Pretty positive. It's fairly steep, right? Okay, so that means when I graph this, in fact, would you say, sort of in a symbolic format, how about we say double positive? It's really positive. Okay, right? So I'm going to graph really positive, right? This graph here is a graph of the slope at that particular instant. It's starting very positive. And what would you say about the slope as you go up like this? What value of slope is it approaching? The slope. What would you say about the slope at the end right here? It's 0. Is it not? Right? In fact, it goes from like double positive, would you say single positive, to 0? Right? So right here, the value of the graph is positive, and then it approaches 0 right at this point right here. Right? So the graph itself goes from very positive to 0. Keeping in mind, the velocity graph is a graph of the slope of the position time graph. Here's where I look up to see if people are nodding their heads because they get it. Yes, Brennan? It helps a lot, you guys. I mean, all you gotta do is just give me this. Just a little bobblehead and I'm good. This one means do more. What's the value of the slope over this interval here? Jared? What's the value of the slope right here? What's the value of the slope? Don't listen to them. Let's think about it, man. You know the answer. It's not hard.
0.
0, absolutely. Which is why this graph right here is at, I'm going to put it in blue. Slope is 0, so where is it graphed?
0.
Right at 0. Right? Okay, Alex, what is happening to the value of the slope over this interval right here? Is it becoming positive or negative? It's becoming more and more negative, right? Steeper and steeper. So the value of the graph moves away from 0, right? It moves away from 0, and it goes more and more negative. Becomes more and more negative. And then, Jake, in this interval here, what's happening? Constant what? Constant negative slope. And so the velocity time graph flattens out and becomes constant negative. Constant negative value, right? The value here is the slope here. Going from this to this, you're looking at the slope and you're graphing. Yes? Slow nod is good. Thank you. No? It seems like you guys are okay with it. Do you have this at the bottom now? Okay. This is the other way. This is going from, this we went from dt to vt. Now we're going the other way. So you got to take your mind and you got to sort of flip it around. Okay? So, this is the slope of this one. We're going the other way. Oh, in fact, I think, if I'm not mistaken, yes. Those two are the same, right? This and this are the same. This is the slope of this graph here. Okay, stop and think. Okay, guys, I need about 5 more minutes, okay? What's the value of the slope right here to start? Is it very negative? Is it 0 or is it positive? It's negative. Remember, I'm not asking you for the slope of this line. This is the velocity time graph. I'm asking for the value along the axis, right? The slope here is negative, and like the value is negative, and it approaches 0. So my slope here is very negative, and as I continue along the interval, the slope gets smaller and smaller and smaller until at this point right here, it is 0, which means the slope of the dt graph is flat. I'm ignoring that. Is that right? Nod. This is crucial here. No, Jake? Yeah? Focus on me, man. Okay. What's the value of the slope right there? 0. Remember, this is a graph of slope, which means my slope is 0 here. And as it moves like this, the slope value, the value of the graph, is becoming more and more positive, which is why the graph here becomes steeper and steeper and steeper. Now, how come it stops there before it gets to the axis? This is not an easy question. How do you know to stop it there? You don't without doing something. Okay? Remember, this is displacement. How do you find displacement from a velocity time graph? You have to find the area, right? And so this area here would actually be the value right there, right? And this area here would be how much it is in positive. Are those two areas the same? At first glance, they kind of look the same, right? And it's really tough to tell because there is no, even if you look in the book, are they exactly the same? Well, the time isn't quite as long, is it? Okay, so that area is not the same, which is why this is negative here. This is positive. So if I go down 5, if this is minus 5, this is only plus 4. So I go down to minus 5 and I go up plus 4, which is why I don't fall all the way to the axis. I wouldn't expect you to get that. That's pretty advanced. You might get it now that I show it to you, but you might not spot it ahead of time. Okay, what's happening to the speed of the object during this interval right here? Constant velocity, Brennan? You're right. Constant velocity, how is that shown on a dt graph? Constant velocity, dt graph. Let's go back to the previous one. Constant velocity on the dt graph. See here, this is exactly the same, right? That dt graph is exactly the same as this one. And what does the velocity time graph look like? Sorry, the displacement time graph. Constant, right? Constant slope. So, That just means that my slope here continues. Now, you will notice in the graph, what would you say about, yeah, it does, doesn't it, right? So what should it really be, Nick? It should be a straight line from there. It should be like that. Someone has messed up in the art department. A minor little boo-boo. Constant. Okay. The value of the graph is positive here, and it goes to 0. So my value of my slope is becoming 0, and so my graph flattens out. This approaches 0. The slope must approach 0. Here the value of the slope is? The value of the graph is 0, which means my slope down here must also be 0, flat. And Chandler, I'm going to leave the last one for you. What's happening to the value here? It's becoming more and more negative, which means my slope must be becoming steeper and must be going down. Right, it's probably more like that, isn't it? Now, I would agree, and you probably would agree with me, that it's easy for me to show you this, and there's the answer. Oh, yeah, I get all that, right? If I cover this all up, if I just say, here's the graph, here's the velocity time graph, you guys make a dt graph, that's a little harder, isn't it? If I show you the answer, you say, oh, yeah, I get that, I see that. But if I say make it, that's a bit harder. On the back side of that Handon assignment, the front side is basically this stuff, right? Which I'm guessing you can probably do. But the back side is this stuff. And I'm not convinced that you've done that backside right. You may have. So what I'm going to suggest you do is try a couple here, page 22 to 28. I have these to give you. On page 71. Did I give you guys these? I don't think I did. I have lots of them. I gave you this one, right? Did I give you guys this? No? Oh, yeah, that's the hand. Okay, so these are the practice ones here. I didn't get it, right? Okay. Well, I don't know. You need that one then? You guys have this? Looks like I need to make a few more. You know this, John? No? Okay. Yeah, I mean, you guys want these, I'm going to talk before. What I'm suggesting, give me 30 seconds. What I really suggest you do is try these practice ones there on page 71, number 22 to 28. I made the graph for you right here. I suggest you try these, get comfortable before you submit that Handon one. Okay? I'm not going to copy. I guess I must have people. You want a Handon one? Yeah, go. Jake.
Oh, I hope mine's on the pen.
Yeah, pen is a bad idea.
Oh, it's not. Mine is in.
Okay, so is everyone clear what I want you to do? You need help, Courtney? Okay, let me find this sheet because I gotta go run this off. And then I'll read it.
Yeah. Yeah. So who knows what we're going? I just know me. I'll be there.
Oh, yeah, sure. But you go with Maggie,
I'll be there. Yeah, I think it's fun.
how's you going? I think Mark could go. That'd be nice. Who? Mark could go.
Yeah.
No, all that, when I mark, I just look at the sheet and sort of above and below and top. In fact, I would almost prefer the almost make because it's really hard to find the graph. It does. It's almost better if it's blank and you have a little more flexibility. Yes, I agree. Does that help? I would suggest you try some of these, and then you can go back and look at these and say, yeah, that makes sense. it is easier.
Well, I have no cheese.
Look, if there was actually numbers on there that you could find still. And then you could make this work, right? You could put the point. I would use that. Okay, I won't run this off.
Count it out.
Yeah, okay. I wanted to see, I wanted to hear this conversation.
Okay.
Where's Pastor?
That's very neat.
Josh, were you at KFC?
What?
Were you at KFC?
Yeah.
Yeah, I saw you coming here.
Sweet man. Holy.
Where did you go?
Cobra, robes, and sauce.
Oh yeah, what's possible?
Yeah, Cobra bought me a big punch combo.
What? You serious?
Well, I'm not over there, but let it bounce in and I'm not.
Do it for me, my name is Kay.
I get fired up. What's your leader? Lane?
I'm named.
No.
As if I got it the first time. Where did you guys? It's so stupid.
We ran because we fired up and we were the same one.
My dad's son love me. Oh, God. Oh, no. Oh, somebody got me.
These documents pop up like what?
I probably bought me some speedy wings today. Woke up, wanted to go out, and then got fucking school. That's my mom, like, making an excuse to eat something.
Go for it.
Why the hell was it till 10:30?
Oh, yeah.
Put it away, crap.
What was it supposed to be doing?
You're right, never mind, I'll put it away. Marty, here's what I'm gonna do for you. I'm gonna mark it, whether it's right or wrong. If it's wrong, I'm just gonna hand it back to you. How's that sound?
I agree.
Hey, Ryan? Okay. Your dad's drive, okay? Oh, yeah? Got home kind of late? For me? Oh, he stayed in on. He's ready to relax. He got a nice steamboat park.
Get back.
What? I parked 10 minutes.